How should the U.S. Navy power its next destroyer? The U.S. Navy has begun the development of a successor to the DDG-51 Arleigh Burke-class destroyers. It plans to break ground on what is currently known as DDG-X in 2030 to replace all of its remaining Ticonderoga-class cruisers and its older Burke destroyers, 49 warships in all. DDG-X will therefore be the Navy's largest surface combat ship construction program until mid-century. Production of the Burke class will end once the lead ship is under construction, leaving only the DDG-X and a sister frigate class called the Constellation class as active programs to update the United States Surface Combatant Force. The frigate's design is now largely stabilized, but the X in DDG-X indicates that the characteristics of the next-generation destroyer have not yet been finalized. The Navy claims it wants a destroyer that, compared to the Burke class, has 50% more range but 25% less fuel consumption while she can stay stationary 120% longer. Mechanical shafts and gears take up valuable room within a warship and are unnecessary with integrated electric propulsion. But what kind of fossil fuel engine should be used to generate the electricity needed for many other applications on board? There are basically two options: diesel or gas turbine, and designers often go for a combination of both. Two different engine types are often favored because gas turbine engines are more efficient at full power, while diesel engines are more efficient at lower revs. However, the logic of this approach is less convincing once integrated electric propulsion is introduced. Why not use just one type of motor if the goal is to generate electricity? The Burke class relies on gas turbine engines, which can efficiently reach peak power. China and the UK are building advanced surface combatants using diesel engines for propulsion and electricity generation. So one of the DDG-X design features that the Navy's Marine Systems Command will have to clarify is whether to continue relying on gas turbines, switch to diesel, or use a combination of both. Given the performance specifications of the DDG-X, there are compelling arguments to abandon gas turbines in favor of a diesel-electric design. That argument starts with large surface combatants operating at speeds well below their maximum design potential, i.e., low to medium speeds. At those typical speeds, when cruising or parked, diesel engines are inherently more fuel efficient than gas turbines. As gas turbines consume more fuel, they reduce the ship's range without refueling, increasing the logistic burden of keeping warships underway. In the vast expanses of the Pacific Ocean, that means needing more tankers to keep ships supplied with fuel, reducing coverage areas, or adding more warships to avoid reducing coverage. Whichever way you look at it, relying on gas turbines has its drawbacks. Diesel's drawbacks become more apparent when a destroyer attempts to keep up with aircraft carriers that can cruise at speeds of more than 30 knots. At top speeds, diesel seems less efficient. But top speed is not how American warships usually operate. Diesel engines have a performance advantage over gas turbines when the goal is to maximize range and fuel economy with a significantly longer dwell time. Diesel's benefit is that it is a tried-and-true technology, and the Navy has stated that it plans to build the destroyer in an evolutionary fashion, no development. Relying exclusively on diesel, as China and Britain have done, could also ease the challenge of electrifying ships. The central question, however, is whether ship designers should favor technology that is more fuel efficient for 90% or more of the time the warship is operating at sub-maximum speeds, or choose the most efficient technology when maximum power is needed in an emergency. The choice is that clear, and, in the end, marine planners and engineers will have to decide. The Navy's willingness to take on life cycle expenditures for a fleet of next-generation destroyers that could number in the dozens will play a role in determining the best course of action. Once again, it is a choice. But if the Navy intends to start building the lead DDG-X class ship in 7 years, the decision will have to be made soon. In 2030, the Navy may have no more Ticonderoga-class cruisers, and the Burke-class destroyer may be too small to perform some of the duties the Navy assigns to its destroyers in the future. Thanks for watching.